Learning objective. Understand how to play, monitor, and control project using PERT and CPM. Ang PERT stand for Program Evaluation Review Technique at CPM stand for Critical Path Method ay dalawang paraan na ginagamit para magplano, magmonitor at magkontrol ng mga gawain sa isang proyekto. Planuhin, ayusin ang mga trabahong kailangan gawin ayon sa tamang pagkakasunod-sunod. I-monitor, bantayan ang aktwal na progreso. Tapos na ba ay isang gawain na antala ba ito? I-kontrolin, gumawa ng aksyon kapag may problema tulad ng pag-adjust sa schedule o pagdagdag ng tao. Next is determine earliest start, earliest finish, latest start, latest finish, and slack time for each activity. Ang earliest start, pinakamaagang oras na maaaring simulan ng isang gawain. At earliest finish naman, pinakamaagang oras na maaaring matapos ang gawain. Then, latest start, pinakahuling oras na pwedeng simulan ang gawain na hindi na naapektuhan sa kabuuang proyekto. Latest finish, pinakahuling oras na pwedeng matapos ang gawain na walang delay sa proyekto. Slack time, ilang araw maaaring maantala ang gawain ng hindi maapektuhan ang deadline. Mahalaga ito para malaman kung kailan ang aktibidad ng critical hindi pwede ma-delay at alin ang may leeway o buffer time. Next is understand the impact of variability in activity time. Dito po is hindi pare-pareho ang bilis dapat aktibidad ng bawat aktibidad. May mga gawain mabilis matapos at may iba namang pwedeng matagalan depende sa kalagayan ng trabaho, availability ng tao at materyales, panahon o mga hindi inaasahang hadlang. Dahil dito, ginagamit natin ang PERT, estimate kung saan tinitingnan ang optimistic time, pinakamaagang posibleng tagal, most likely time, pinakamaagang tagal, pinakakaraniwang tagal, pessimistic time, pinakamahabang posibleng tagal. Ginagamit ito para makuha ang average expected time at malaman ang probabilidad na matatapos ang proyekto sa takdang oras. Last is understand the important role of software such as Microsoft Project and Project Management. Ang Microsoft Project at iba pang project management software tulad ng Primavera, Trello or Asana ay tumutulong para ayusin ang schedule, matatagalan ang mga tao at kagamitan, mas subaybayan ang proseso, magbigay ng babala kung may delay o kulang sa resources. Malaki ang inaitutulong ng mga tools na ito sa mas maayos na project management gamit ang Gantt chart or virtual timelines. Project planning. Specific question, what are the considered? First is what is the goal or objective or of project? Halimbawa, makabuo ng 10 furniture para sa exhibit. Second, what are various activities or tasks that constitute project? Halimbawa po is cutting, sanding, painting, assembling, last is packaging. Third question, how are these activities like? Kailangan matapos muna ang cutting bago simulan po ang sanding. What are the precedence relationship between activities? First is cutting, second sanding, next is painting, next assembly, plus is delivery or pick up. What is time required for each activity? Halimbawa po is cutting is 2 days po, and then yung Sunday is sanding 1 day is 1 day. What other source such as labor, raw materials, and machinery are required for each activity? Mga manggagawa materials katulad po ng kahoy, pintura, at kagamitan mga tools po, sander, spray gun. Project scheduling. Question to be answered. When will project be completed? Ayon sa schedule, ang lahat ng aktibidad kailangan inaasahang matapos. What is schedule or each activity? Halimbawa po sa cutting is nag-start po tayo ng June 1 hanggang June 2 po yun. Ang sanding naman po is 1 day. Then the next day po, June 3 po yung sanding, and painting po June 4 and June 5, 2 days po yung painting, and assemble po is June 6. Last po is package yung June 7, 7 days po natin po. What are critical activities in project? Mga aktibidad na hindi maaaring maantala kapag na-delay sila, maantala rin ang buong proyekto. What are non-critical activity? Mga gawain na maaaring maantala ng kaunti dahil may slack time, hindi sila nasa critical path. By how much can a non-critical activity be delayed without affecting completion time or entire project? Slack time, halimbawa kung may 2 araw na slack, maaaring ma-delay ng dalawa nang walang apekto sa proyekto. Plus, if a variability is activity time is considered, what is probability project will be completed by specific deadline. Sa pamagitan ng PERT, makukuha ang probabilidad, halimbawa po is 85% na chance na matatapos sa loob ng 10 araw. Batay po sa OM at P time estimated. Project control of large project involves close monitoring of schedules, resource, and budget. Question to be answered. At any particular date or time is project on schedule, behind schedule, or ahead of schedule? Layunin alamin kung ang proyekto ay sumusunod sa plano o may delay. Paano po malalaman? Ikumpara ang plan, schedule, ganun dapat katagal, sa actual process, ganun gaano na natapos. Halimbawa, kung dapat ay 50% na ang natapos sa isang araw na ito, pero 30% pa lang, nahuhuli na po yung project. At any particular day or time, is money spent on project equal to less than or greater than budget amount? Layunin i-monitor ang gastos at maiwasan ang overspending. Paano po malalaman? Ikumpara ang budgeted cost sa actual cost ng mga natapos na aktibidad. Gumamit ng tools katulad ng Earned Value Management, EVM, para masukat ito. Halimbawa po, budget for June is 100,000. Tapos yung nagastos is 120,000. Overspend, lumalampas sa budget ng 20,000 po. Are there enough resource available to finish project on time? Tiyakin sapat. Layunin po natin, tiyakin sapat ang lahat ng kailangan upang hindi maantala ang proyekto. Tinitingnan ang availability ng tao or mga labor, manager, at etc. Kagamitan like tools, machines, mga materyales, raw materials. Halimbawa, kulang ang kahoy sa gitna ng project, maantala po yung ating posible talaga madilim. Last is, if project is to be finished in shorter amount of time, what is the best way to accomplish this is less cost? Mabilis ang matapos ang proyekto nang hindi gaano gumastos. Dalawang paraan: crush, pagdagdag ng tao, overtime o resources sa critical activities para mapabilis lahat tulad ng gastos. Mas mabilis pero mas mahal. Fast tracking, pagsabay-sabay ng ilang aktibidad na dati ay sunod-sunod. Mas mabilis nang walang dagdag na gastos pero may risk, baka makamali o mag-overlap. Halimbawa, estimated na matapos ang design bago ang fabrication. Gawin ito ng sabay, risk pero mabilis. Ang project controlling ay parang check-up ng proyekto. Tinitingnan mo kung ito'y nasa tamang landas ba ang schedule, nasa budget pa ang gastos, may sapat bang gamit at tao, at kung kailangan mabilisan, paano ito magagawa ang hindi gumagastos ng sobra.
Chart for new voice recognition. Project activities: A. Design system. B. Build prototype. Z. Test prototype. D. Estimate material cost. E. Estimate labor cost. F. Refine design. G. Build the final product. H. Demonstrate the product. And I. Market the product. So, for example, for this activity, for example, sa design activity, which is, mayroon siya sang start date, for example, April 1, and then end date, April 30, and then duration for this schedule is 1 month. So, another example, demonstrate the product. Example, within August 1 and August 18. So duration is 15 days. Depended bold final product. Project network. There are two major approach for drawing a project network: activity on node and activity on AOA. Although both approaches are popular in project practice, include Microsoft Project 2000 use on activity on node network focus its own network. So, for example, two major type of project network. Number 1 is activity on node. For example, gather materials within 2 days. Example number 2, build prototype 3 days. Start after A. Test prototype 1 day. Start after build prototype. So for this activity can show more complex relationships, start to start or finish to finish. So activity on so number 2, activity on arrow. Same task, gather materials, build prototype, test prototype. For this activity, for example, so show that start at the end points activity. So example sini, so halimbawa sa magtanom ka sang mga halaman or something nga gulay. So which is damo siya sang proseso. So kailangan mo anay bungkag sang lupa, magbuhos sang compost o magtanim ng mga binhi, and then idiligan mo ito para para kumbaga ang proseso mo is hindi siya ma-delay and then on time siya. So ang different between activity on node and activity on arrow. So ito ay tumutukoy sa activity on node, tumutukoy sa simula at katapusan na aktibidad. And then sa activity on arrow, tumutukoy sa mismong aktibidad. CPM, PERT. CPM, start for critical path method. It is project scheduling with known activity term. PERT, stand for program evaluation and technique. It is a project scheduling with uncertain activity time. PERT, CPM is used to plan the scheduling of individual activities that make up a project. PERT CPM can be used to determine the earliest, latest start and finish time for each activity, that entire project completion time and the slack time for each activity. So, critical path method. So, ang pinakamahabang sunod-sunod na mga gawain na nagtatakda ng mga produkto. So, PERT o Program Evaluation Review Technique, nagtutukoy sa oras ng mga gawain na nagsasaliksik ng mga critical na gawain sa landas upang matiyak ang maayos na pagtatapos ng proyekto. So, CPM and PERT. Ito ay tumutukoy kung gaano katagal ang bawat gawain, alin sa mga gawain ang pinaka-critical na hindi pwedeng ma-delay. Kailangan magtatapos ang buong proyekto. CPM and PERT. So, CPM is critical path method, and then PERT is stand for Program Evaluation Review Technique. So, network technique developed in 1950s. CPM by default from chemical plant 1957. PERT by boats Allen Hamilton with the US Navy for Polaris missile 1958. Consider precedence, relationship, and interdependence. Each uses a different estimate of activities time.
Next is a project network. A project network can be constructed to the model of the precedence of the activities. The nodes of the network represent the activities. The arcs of the network reflects the precedence relationship of the activities. A critical path of the network is a path consisting of activities with zero slacks. So in short, So in short, the project networks are powerful tools for, visualizing project timelines, identifying dependencies, and determining the shortest possible project duration. They are essential for effective project planning and control. And the next is determining the critical path. Step 1. Make a forward pass through the network as follows. For each activity I, beginning at the start node, compute. Early start time equals the maximum of the earliest finish times of all activities immediately preceding activity I. This is 0 for an activity with no predecessors. Earliest finish time equals earliest start time plus time to complete activity. The project completion time is the maximum of the earliest finish times at the finish node. Step 2. Make a backwards pass through the network as follows. Move sequentially backward from the finish node to the start nodes at a given node J. Consider all activities ending at nodes J. For each of these activities, I and J compute. Latest finish time equals the minimum of the latest start times beginning at node J. For node N, this is the project complete time. Latest start time equals latest finish time minus time to complete activity I and J. Step 3. Calculate the slack time for each activity by slack equals latest start minus earliest start or equals latest finish minus earliest finish. A critical path is a path of activities from the start node to the finish node with zero slack times.
So our next slide is uncertain activities. So that slide is the 3-point estimated method used in project management to account for uncertainty in activity duration. This uses the beta distribution to model the time it takes to complete a task. So the 3-point estimate approach, this method acknowledges the estimating task duration and inherently uncertain. Instead of single est- estimate, it uses three values. So the A here is represent the optimistic estimate, the shortest possible time to complete the activity under ideal condition. So so the letter M here is represent the most likely estimated, the most probable time to complete the activity. So the B is represent the pessimistic estimate. This is the longest possible time to complete the activity under unfavorable condition. So when we say the beta distribution is is a probability distribution often used for model events with a known minimum and maximum value, and most likely a value the shape of distribution affects the uncertainty around the task duration. So to calculate the mean completion time, T, the formula of this is T is equal to A plus and for A plus for M plus B divided by 6 mean or the mean. So it calculates the weighted average of the three estimated. The most likely estimated M is weighted more heavily 4 times than the optimistic A and pessimistic and B estimated reflecting its highly probability. So to calculating the variance of S squared, the formula of this is S squared equal to B minus A and divided by 6 times the square root. So to calculate the variance which measures the spread of this precision of this possible completion times a largest variance indicates greater uncertainty in the task duration. The range B minus A, a wider range implies more uncertainty. So the critical path in the project management, the critical path is a sequence of activities that determines the shortest possible duration of the entire project. Any delay in this activity directly delays the project completion. So the variance of the critical path 0 raised to 2. The formula of this is 0 raised to 2 is called the sum of s squared. So calculate the overall variance of the critical path by summing the variance s squared of all activities. Along the critical path provides a measure of the overall project completion time. Certainly, a higher variance for the critical path indicates a higher risk of project delays. So this, in the short term, the three-point estimated methods provides a more realistic way to estimate task duration than the single point estimate by considering uncertainty. So it uses the beta distribution to model uncertainty and provides tools to calculate both the expected completion time and the variance, which is crucial for risk assessment and project planning. So here the next slide here's explain how to estimate the overall project completion time using the three-point estimation method. So the critical path determination or the critical path is the longest sequence of the task determining the project's minimum duration. Is identified if each task took its mean completion time. So in the normal distribution assumption, the overall project completion time is then assumed to follow normal distribution. The mean of distribution in the sum of the mean times of all tasks on the critical path. The variance is the sum of the variances of all tasks to the critical path. This allows for probabilistic statements about the project's likely completion time. So the next slide is project crashing, a technique used to shorten a project schedule when facing a deadline. In the starting point, the project crashing begins with a normal project schedule, including the critical path, or the longest sequence of the tasks determining the project duration. And the normal cost is the cost associated with completing each activity using standard procedure and resources. So the deadline issues, if the initial schedule doesn't meet the required deadline, crossing becomes necessary. So this involves taking extraordinary measures to reduce task duration. So in crash time, this shortest possible time to complete an activity. Achieving this typically requires additional resources, more people, better equipment, overtime, and etc. To increase the cost. So the crash cost, this represents the extra cost incurred to reduce an activity duration. It is a crash time. It's difference between the normal cost and accelerated cost. In essence, the project crashing involves strategically shortening the duration of specific activities along the critical path to meet a deadline, but at an increase of but an increased cost. The project manager needs to carefully analyze which activities to crash and balance the cost of crashing against the benefit of meeting the deadline. So the slide presents an example project of constructing a new building outline the activities, their dependencies to create a project network. So the goal of this is the ultimate objective is to create the project networks diagram. This diagram usually represent the sequence of tasks, their interdependencies, helping to manage the project's timeline and identify the critical path. So here, as we can see in the table, there's the activity, description, and predecessors. So in the activity here, we all can see that activity A, B, C, D, E, F, G, H. And the description here is, as you can see that there is a service side, initial design, obtain approval completion, select architect, establish budget, and finalize design, and obtain financing, and hire contractor are secured. So here, in a survey site, the project started with a survey site. So the next is the initial design. Initial designs can start independently of the start site survey. So the obtain in the activity C, the A and B approval depends on both site survey and initial design completion. So in activity D is selecting an architect happens after approval is obtained. So we put the letter C on the letter D to select an architect happens after approval is obtained. So in the letter E, we put letter C also to establishing the budget follows project approval. So in the letter F, we put the D and E, which is final design requires architect selection and budget approval. And the letter G, obtain financing. We put letter A, the financing needs are fulfilled once the budget is established. And letter H, we put FG, which is hiring a contractor happens after final design and financing are secured. So the predecessors here is the column indicates which activity must be completed before another activity can begin. So for example, the activity C, the obtain approval requires both activity A and B to be finished first. So creating the network, the final instruction to draw the network of this project implies the next step is to create a visual representation of the network diagram, often using a Gantt chart, so or a network graph. So the slide presents an example project of constructing a new building, outline the activities, their dependencies to create a project network. So the goal of this is the ultimate objective is to create the project networks diagram. This diagram usually represent the sequence of tasks, their interdependencies, helping to manage the project's timeline and identify the critical path. So here, as we can see in the table, there's the activity, description, and predecessors. So in the activity here, we all can see that activity A, B, C, D, E, F, G, H. And the description here is, as you can see that there is a service side, initial design, obtain approval completion, select architect, establish budget, and finalize design, and obtain financing, and hire contractor are secured. So here, in a survey site, the project started with the survey site. So the next is the initial design. Initial designs can start independently of the start site survey. So the obtain in the activity C, the A and B approval depends on both site survey and initial design completion. So in activity D is selecting an architect happens after approval is obtained. So we put the letter C on the letter D to select an architect happens after approval is obtained. So in the letter E, we put letter C also to establishing the budget allows follows project approval. So in the letter F, we put the D and E, which is final design requires architect selection and budget approval. And the letter G, obtain financing. We put letter A, the financing needs are fulfilled once the budget is established. And letter H, we put FG, which is hiring a contractor happens after final design and financing are secured. So the predecessors here is the column indicates which activity must be completed before another activity can begin. So for example, the activity C, the obtain approval requires both activity A and B to be finished first. So creating the network, the final instruction to draw the network of this project implies the next step is to create a visual representation of the network diagram, often using a Gantt chart, so or a network graph. So the next slides here represent a second example using the critical path method or the CPM and project management. The goal is to determine the project duration and create a schedule. So the CPM is a technique for planning and scheduling project. It identifies the critical path. The sequence of the task determines the shortest possible project duration. Any delay on a critical path directly impacts the overall project completion.
For the next table, we have the Program Evaluation and Review Technique, or PERD. For the following activities and their predecessors for 3 times estimate by the activity predecessors optimistic, most probable, and pessimistic. Compute the expected completion time for each activity. PERT uses 3-time estimate for each activity to account for uncertainty. Optimistic time, the shortest possible time to complete the activity under ideal condition. Most likely time, the most probable time to complete the activity. Pessimistic time, the longest possible time to complete the activity and unfavorable condition. The expected completion time for each activity is calculated using the following formula of TE plus A. TE is equals to A plus 4M plus B divided by 6. So let's calculate the expected completion time for each activity. For activity A, T is equals to 4 plus 4 plus 7.5 plus 8. Then, i-divide siya sa 6. So, ang iyang answer is equals to 7. For activity 7, PE is equals to 1 plus 4 plus 2 plus 3. Then, divide siya sa 6. So, ang iyang answer is equals to 2. For activity C, TE plus 4 plus 5 plus 6. Divide siya by 6. The answer is
is equals to 5. For activity D, TE is equals to 7 plus 4 plus 8 plus 9 divided by 6. Ang answer niya is equals to 8. For activity E, TE is equals to 6 plus 4 plus 7 plus 14, then divided by 6 is equals to 8. The solution assumes that activity duration are independent and follow the beta distribution, which is the common assumption in PERT analysis. The accuracy of the probability calculation depends on this assumption and the accuracy of the time estimate. Real-world projects often have depends and is under, under understanding that are difficult to fully capture in the PERT analysis. Yun lang po at maraming salamat. The critical path is the sequence of activities with the longest total duration from the start to finish. Activities on the critical path have zero slack. LS minus ES is equals to 0 and the LF minus EF is equals to 0. And any delay in these activities will directly delay the entire project. To calculate the total project duration, the total project duration is the sum of durations of the activity on the critical path. This is the shortest possible time to complete the project. For example of calculating activity A, ES minus 0, EF minus 0 plus 12 is equal to 12. Activity B, ES is equals to 0, EF is equals to 0 plus 16 is equals to 16. Activity C, ES plus maximum 12 and 16 is equals to 16, EF plus 16 plus 24 is equals to 40. Since C depends on A and B, the ES is the largest of A and B.